Well, we have another question here, question 5. The question says that the sketch below is the graph of f of x equal to k to the power of x, where k is greater than 0. The equation, the point 416 lies on f. Now, question 5.1 here says determine the equation, or determine the value of k. Okay, I'm writing my question here. 5.1, we're looking for the value of k. And then f of k, f of x actually is given by k to the power of x. Excuse me. Now, how can we do that? Now, we can notice that we have like 2 points here. Points there and the intercepts. This means x is 0 and then y is 1. And we've also have another points there on that line. Those points lies on the graph of f. Now we can use the point to substitute in order to find k, but what point can we take then? Now let's see if I selected the point 0, 1, what will happen? Now if I sub like sub 0, 1, okay, we do know that if I sub 0, 1, the function f, okay, the function f will be like y equal to k to the power of x, right? And if I sub the point 0, 1, it means y will be 1, and then x will be 0, okay? And then k to the power of 0 will be 1. So we have like an equality here, 1 equal 1. It didn't solve the value of k. Now, I want you to notice something. Never do something like that. Okay, 1 is like 1 to the power of 0. Oh, then we're going to equate, and then we say therefore k equal 1. K equal 1. Oof, please. Careful here. Don't do this. Okay, it's wrong. Now, in this case, you shouldn't do that. This is wrong. So what you can do, sub the other points. Okay, sub the point 416. If, for instance, we sub the points, subbing the points 4 and 16, this will be then. So we'd have like f will be equal to. Okay, f, the function f will be y equal to k to the power of x. So we sub in the points 16 for y and then 4 for x. So 16 equal to k to the power of 4, right? Now, a situation like this, we must write the numbers in terms of their prime factor. So 16 is like 2 to the power of 4. And then k is also, okay, there we have k to the power of 4. Now there's a property in math that says this. I'll write it here. If a to the power of m equal to b to the power of n, okay? No, to the power of m. When the exponents are common like this, then a equal to b. So in this situation, because we have like exponents common, okay, then we say therefore 2 is equal to k, or k equal to 2. So this is the value of k. Okay. Now, the following question says, the following question says that graph G is obtained by reflecting GF about, by reflecting the graph f about the line y equal x. Determine the equation of G in the form y equal to. Well, I want you to notice that this statement, okay, reflecting about the line y equal x simply means, this simply means that G is the same thing as f, is the inverse of f, okay? So I prefer to, okay, I'm gonna move my board over here. So 5.2. Let's do it here. So we're looking for the equation of g of x, okay, in the form y equal to. And then we said that g of x is the same thing as it's just equal to f minus 1. Now, f of x was given by k, okay, y equal to k to the power of x, but we know the value of k now. K is 2, so we're gonna say y equal to 2 to the power of x. Okay. Now, to find the inverse, then f minus 1 is when we switch the variables. Okay, we call y x, and then we call x y. So this is like x equal to 2 to the power of y. Now we're going to make y subject of the formula. So I'll prefer to reverse write like this: 2y equal to x. So if I need to find the value of y, I can use the log properties. Okay, you know, you must know that b to the power of x equal a implies that log of a, sorry, I prefer to write this way, implies that x equal to log of a base b. Okay, so in this situation, my x is y, okay, because exponent x here is y, so I'm gonna say y will be equal to, okay, because we have like 2 to the power of x equal to x, we have this, so I need to get that. So y will be equal to log of a, which is x, and then base is 2. So we have like that. So therefore, that's g of x. Thank you. And then the next question is question 5.3. We have this question here. The question says that sketch the graph G indicates on your graph the coordinates of 2 points on G. Now, we're going to draw the graph of G. So I will split my board again like this. Okay, I prefer to represent the same diagram over here again. So on the right here, 5.3. So here we're going to do the sketch of G. And I'll move it over here like that. And now, okay, here is the diagram that we had. Then we're going to draw another graph similar to this, a log function. Now, it is important because we need to draw the graph of g of x, okay, which is the same thing as the inverse of f of x. Now, we did find that g of x is just log of x base 2. So, you know, log this one, to do the graph of this, we need to find the intercepts, okay? This is like y equal to, excuse me, log of x base 2. Now, if I need to find the x-intercept, x-int simply means make y equal to 0. So we will have like 0 equal to log of x base 2. Okay, so this means like log of x base 2 equal to 0. According to our log property, this means x will be equal to 2 to the power of 0, and then 2 to the power of 0 just 1. So the x-intercept, let's say 1 is somewhere there. Okay, and then y-int, actually it doesn't have y-int, but I just want to show you. Y-int means x equal to 0. So in this situation, if I do we have like y equal to log of 0, okay, base 2. This, if you try log of 0, log doesn't accept values that are 0 or less than that. If you try to calculate a log of 0, you're going to get something like log of 0, regardless of the base. This is undefined, it's a math error. Okay, so this is error. Now it doesn't have the y-intercept. So the graph of logs here will be then this one. Oops, my graph mustn't be that straight. Goes through the intercept. So here intercept is 1. Okay, and then the following question is a question 5.4. Excuse me. The question says, use your graph to determine the value or values of x for which f of x times g of x is positive and g of x is lesser than -1. So we're going to use the graph for that. Now 5.4, I'm gonna move my boot here like that. So let's write it here, 5.4.1. So we need to prove that f of x, okay, times g of x is positive. How can we? Okay, I need to state some conditions here. We can have positive. This product can be positive only if they have same signs. Okay, if they're either both positive or both negative. Okay, and if the sign alternates, then they're not positive, because positive times positive makes positive, negative times negative makes positive as well. Now we can see that the two graphs will be positive when they're in the interval 1. Okay, if x is 1, the g will be positive. Okay, and then this one also will be positive when x is equal to 1. That will be positive here. Is greater than 1, I mean. So I'll say if x is greater than 1, and then they're both negative. Where are they both negative as also? Let's see. The exponential function will always be positive. So the answer is just x is greater than 1. So this is the answer here. Okay, or someone can write it like x is elements of the interval from 1 to infinite. You can also write this way. Okay, and then 5.4.2, it says g of x, okay, is lesser than or equal to -1. All right, how can we do this one? Okay. Lesser than -1 is like g of x plus 1 will be less than or equal to 0. In which interval? So it means that g of x plus 1 less than or equal to 0. Positive 1 indicates a vertical shift. So this shift, the graph is shifted 1 unit upward. Okay, so in which interval we're gonna be? What should be the value of x? Now it may be difficult to see that from the equation, from if I just write g of x, but I prefer to keep it in this form now. So g of x is a log of x base 2 must be less than or equal to -1. Now this means, according to the log properties, that x must be less than or equal to 2 to the -1. Okay, and then that means x must be less than or equal to 1/2. Now remember, the value of the logs are only logs can only accept value that are zero, actually more than 0. So therefore here the values of x will be those values that's going to be from 0 to 1/2. Thank you. Then the following question must be question 5.5. Let's see. Question 5.5 says that excuse me, if h of x equal to f minus 1 of if h of x equal to f of minus x, calculate the value of x for which f of x minus h of x equal to 15/4. All right, we're going to do that over here. Let me read the question over. If h of x equal to f of minus x, calculate the value of x for which f of x minus h of x equal to 15/4. All right. Now, I'll move the board somewhere. So 5.5. It did say that h of x equal to f of minus x. And also, the question says that f of x minus minus h of x will be equal to 15/4. So now we're looking for the value or values of x. Okay, given the information above. Now let me move this for space. All right. Now I prefer to write it this way. F, okay. F of x was given by k to the power of x, and then k we found it was 2, so 2 to the power of x. Okay. Therefore, f minus x will be 2 to the negative x. Okay. So we know that this is just h of x. That's something as h of x. So if we do now this part, we're gonna write now f of x minus h of x equal 15/4. This is just 2 to the x minus 2 to the negative x equals to 15/4. Okay. This can be written as 2 to the x. Okay. There is no property for working out this just as because they have same basis. This is a negative sign and the exponents are not the same. So we can write 2x minus 1/2 to the x. Okay, I apply this property that says 1/a to the m equal to a to the negative m. So this will be equal to 15/4. Then I prefer to write it with a common denominator, or maybe I can introduce something new. I can say, let's say 2 to the x equal to n, for instance. Okay, let n equal to 2 to the x. So this will become then n minus 1 over n equal to 15 over 4. So if we times the whole equation by n again to cancel, just because I want to get rid of this denominator of n, so I will do like our times here by n. This will be n minus 1 over n equal to 15 over 4 times by n. And then this would make what? So we do n times n, and then n times 1 over n. So this will make n squared minus n times 1 over n just 1, okay? Because it's like n times 1 over n, like that, and equal to 15 over 4n. Now, these n and n cancel out, so we have left with n squared minus, we are left with n squared minus 1. If I move the 15, negative 15 over 4, n here equal to 0. Okay, so I don't want the denominator. I don't like do the work with the denominator, so I can get rid of it. If I times the whole equation by 4, this time I times everything by 4 again, and then this will become like 4n squared minus 4 minus 15n equal to 0. Okay, so we can just write it in ascending order of exponents. Okay, minus 4 equal to 0. Now we have a quadratic equation or a trinomial. We can solve this. Let's solve it by factorization. Okay. How can I do that? Because this time we have a leading coefficient here different than 1. So I cannot just put n in the bracket. So this is what I can do. I'll take 4 times by negative 4 here. They make negative 16. Now I'm going to list all the factors of 16. They are 1 and 16, 2 and 8, 4 and 4. Now I'm going to ask myself which couple here will make a sum equal to negative 15. You know that with 4 and 4 we cannot get negative 16, neither will 2 and 8, but with 1 and 16, yes we can, if it's positive 1 here and negative 16. And if you check, 1 times negative 16 is negative 16. So we're going to write over here like 4n squared. Instead of me writing negative 15n, I'm going to write plus 1n minus 16n minus 4 equal to 0. If you're unsure how to do this, I did plenty of these problems when we were doing algebra. We have like 100 questions. 100 questions on this. So how to factorize. Now, you can check the playlist, algebra, you see many questions solved there on factorization. Now over here, I split it into 4 terms, okay? We can take n as a common factor for the first 2 terms, this one and that one. And then we will have like, it's gonna be like 4, left is 4n plus 1. And then for the last 2 terms, also we can take a negative 4 as the common factor because that's the only common factor, the highest common factor. And then by doing that, it will be 4n here and then plus 1. Important, be careful here. We take negative 4 out, okay? So if you times back negative 4, you get negative 16n. Negative 4 times positive 1, you got negative 4n. So if you take a negative number outside the bracket as a common factor, it affects also the signs of what is inside the bracket. Now you'll notice that what is in the brackets here and there must always be the same. If they're not the same, it means either you selected the wrong factors here, or calculations were not correct over here. So now this makes what? This makes n minus 1 times 4n plus 1. No, n minus 4 times 4n plus 1 equal to 0. So that means n minus 4 is 0, or 4n plus 1 is 0. Okay, so I can just move it like that. And then this means that n equal to 4, or 4n equal to -1. Now, this means that n equal to -1/4. So remember, we did set 2 to the power of x was equal to n. Okay, so we can bring back 2 to the power of x is equal to 4, or 2 to the power of x equal to -1/4. Now, for this latest formula solution here, this is not applicable because remember, exponential function, okay, is always positive. Okay, so then over here, this means that 2 to the power of x equal to 2 squared. Okay, and then we do have like some basis here. So what we do in this situation, according to the law of exponents, it says like if a to the m equal to a to the n, then m equal n. So this means that x equal to 2. So that's the value of x in the question. Thank you.